Welcome back to Table Talks. We are still in projectile motion and we are looking at numerical problem number 7, and this will be the last for this topic. Go out to other sources, go to Roger Mungaster, go to Nelcon and Parker. You will find more interesting examples. So our question reads that a particle is projected horizontal at 20 meters per second from a point of 78.4 meters above the horizontal surface. We are required to find the time for which the particle reaches the horizontal surface and then the horizontal distance covered. So let's try to sketch. If this is the horizontal surface, but they say this particle is projected from a place that is 78.4 meters high and is projected horizontally. Now for horizontal projection, it means that the angle of projection is 0. That is what you should know. The angle of projection is always what? Is always 0. Angle of projection for horizontal motion is always 0. We can write it as an NB that the angle of projection for horizontal projection is 0. Take note of that. And therefore this particle has its velocity has no vertical component, or the acceleration here is 0. The acceleration is also equal to what? It becomes 0, as we shall see. Now let's look at this particle. We know that S is given the expression ut plus a half gt squared. Now, what do we need? We need the time for which this particle moves that distance. The vertical distance moved is 78.4, which is equal to the initial velocity. This is 20 times t. But we have said that for horizontal motion, acceleration is 0. So the whole of that term becomes a 0. So our t is supposed to be got from the expression 78.4 divided by 20. Therefore, the time of motion is 3.9 seconds. That is what we get. And this being that, this is the time, we have said that g is equal to what? To 0 for vertical motion. The acceleration a is 0. Okay? The acceleration a is what? Is 0 for horizontal projection. Now this was a solution to Roman numeral 1. Now Roman numeral 2 was asking, or it is the same question, in fact there is no Roman, the horizontal distance covered. Now we know from primary even that distance is equal to speed times time. So our horizontal distance here is going to be the speed of projection, which is 20 times time, which is 3.92 times 20. So also the horizontal distance covered is 78.4 meters. It is the same as the point above the ground from which this particle was projected.